No. Okay. So I can't simplify 900ths. I can't simplify 2027. So this is when I want to look across. Okay. So 20 and 100. Is there a number that goes into both of those numbers? What goes in there?
10.
Okay. 5 works. 10 works. Is there anything else?
20.
20 also works. Okay. Do we want to pick a big number or a small number?
Big.
I'd like to pick a big number. So how many 20s are in 20?
1.
1. How many 20s are in 100? 5. Okay, does everybody understand what I did? I didn't cross multiply, I cross simplified. Okay. Now this is going to make my life easier, but I want to check this way just in case. Okay, 9 and 27. Is there a number that goes into both?
Yes.
What goes into both?
9.
Okay, 9.
9.
Could I also say 3? Yes, but again, you want to pick the biggest number. How many 9s are in 9?
1.
How many are in 27? It is very important to make sure you draw a line through it so that you know, hey, don't use this number. Now look how easy my numbers are. 1 times 1, 1. 5 times 3, 15. Okay? If you did not do that, you would have done 180 over 270, divided by 3, 6 over 90, divided by 3, 2 over 30, divided by 2, 1/15. Which one's easier? Simplifying first or last? First.
Simplifying first.
Yes, try to simplify first. It makes your life easier. Okay? Next, 5/8 and 16 25ths. Okay? I can't simplify 5/8. I can't simplify 16 25ths. But let me see if I can cross simplify. Can I? Yeah, what goes in there?
Yes.
8. How many 8s are in 8?
8.
1. How many 8s are in 16?
2.
2. Okay? Now I'm going to check this one. Most of the time, both can't simplify, but these can. What goes in there?
5.
5. How many 5s are in 5? In 25? 5. Now I'm left with 1 times 2 and 1 times 5. Okay. All right, last one. 2/3 times 12 over 15. Okay. Can you simplify 2/3? No. Can you simplify 12/15?
No.
Yes. What can you simplify 12/15 by? 3. How many 3s are in 12? How many 3s are in 15? 5. Okay, if you did not know that, then obviously you wouldn't simplify that way. You could have simplified this way. But now, can I simplify 2/5? No. Can I simplify 4/3? No. So now I just multiply. 2 times 4, 8. 3 times 5, 15. Okay? So this is called cross simplify. If you can do this, it's going to save you time and headache. Okay? Again, if not, you would have got 24 over 45, and a lot of you would have stopped because you don't know your 3's very well. Okay? So try to cross simplify. All right, now let's go ahead and turn to page 54, I think. Does page 54 say dependent? Yeah. All right, 54. Before we take these notes, I need to introduce some vocab to you that you're going to see today. Prime versus composite. You learned about prime and composite numbers in elementary school. Does anybody remember what a prime number is?
With a number with one or more factors? Factors?
That's a composite number.
Oh.
So, but perfect. I'm glad you knew the definition. Prime can only be divided by 1 and itself. So no other number can go into it except for 1 and itself. Okay. When I taught 6th grade, I taught my kids this little saying. At 2:35, I went to 7-Eleven to buy some Lucky 13s. I'll explain to you what it means after you write it down. At 2:35, I went to 7-Eleven to buy some Lucky 13s. This little sentence helps you to remember what the first prime numbers are, okay? The first prime numbers. So the first prime numbers are 2, 3, 5, 7, 11, 13. Okay? If you can remember that, that helps you to remember that 1 is not prime. Okay? 1 is special. If I can spell special correct, S-P-E-C-I-A. Yeah. 1 is a special number. It is not prime and it's not composite. You really, really need to remember that. 1 is special. It's not prime. It's not composite. Composite means it can be divided by any other number. So maybe 2, maybe 3, maybe 5. But prime cannot be divided by anything else. Okay? So 2, 3, 5, 7, 11, 13. This is just to help you remember. Now, do you think all odd numbers are prime?
No.
No. What's an odd number that's not prime? Okay, 1 is not prime. Is there another one? 15. Good, to treat. 15 can be divided by 5 and 3. 21 can be divided by 7 and 3. 51 can be divided by 3 and 17. So you can't just assume. Good. 9. You cannot assume that all odd numbers are prime. Okay. All right. Now let's talk about dependent events. When the outcome of one event impacts the outcome of the other. So I have these little colored cubes. Okay. If I said, what's the probability of getting a yellow? What would you tell me?
4 out of 8.
4 out of 8. Okay. And then I said, I'm keeping the yellow one, and now Miss Fiver is going to draw one. What's the probability of her getting a red? 2 out of 7. What happened to my denominator? It changed. Okay. Mine was 4 eighths. Miss Fiver's was 2 sevenths. Okay. So the denominator went down by how many? Only by 1. Okay. There were 4 yellows, but how many yellows did I draw? 1. I only drew 1 yellow. Okay. Now, what if I said, what's the probability of me drawing a yellow and Miss Fiver drawing a yellow? Okay, so I drew 1, 4 eighths. What's the chances Miss Fiver is going to draw a yellow? 3 out of 7. Okay, so notice the numerator changed because it was the same. If I'm drawing the same thing or picking the same thing, then both numbers change. But every single time I don't put it back, your denominator changes by 1. Okay, even though there were 4 yellows, I didn't take all 4, I took 1. Okay, so dependent means your denominator changes. It goes down by 1. Your denominator goes down by 1. If there are 5 colors of Starburst and Miss Fivery takes one and she eats it, am I able to eat the one that she took? No, okay? It didn't say she doesn't put it back, but obviously you know if someone eats something that's not there, okay? So a lot of times they use that to try to make sure that you know what's happening, okay? So let's look at some options and let's see if they're independent or dependent. Flipping a coin. One lands on heads, one lands on tails. Is that independent or dependent? Do two coins have any impact on each other? No. If it has no impact, it is independent. Okay. We have 30 people on our football team, and we're going to choose a captain. My odds of getting picked to be captain are 1 out of 30. Okay. And then we want to pick a co-captain. Does the total change if I've already picked a captain? Yes. So I can't be in there, so now there's 29. So since the total changed, what does that mean? Dependent. Good.
It's dependent.
Good. Okay. You draw a joker, and then you draw an ace. Did I put it back? No, it does not say anything about me putting it back, so it's dependent. Okay. Last time, I made y'all circle and highlight all these words. Replaces, 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 returns it, replaces, returns it. Okay. If you're not returning it, it's dependent. Okay. The next one, you draw a queen, replace it, and draw a 10. Independent or dependent? You replace it. I put it back. It's independent. Good. Because I put it back. It's independent, so my total is still going to be 52 cards. And then you flip a coin and you roll a dice. Do these have any impact on each other? So what would that make it? Independent. Okay, it's going to be very important for you to know independent or dependent. Okay. All right. So now let's look at solving them. You solve them the exact same way. It's just when you have a dependent, your denominator goes down. Okay? So it's the probability of A times the probability of B, which is what we have been doing. This is the exact same thing, but it's after A happens. And our denominator goes down by 1. It only goes down by 1. Even if there's 7 to pick from, I'm only picking 1. All right. Who are my people that like to read? Okay, go ahead, Almond. Thank you.
Noel goes to the pet shop and selects a treat for his dog. He chooses one, then chooses another. What is the probability that Noel selects a bone and then a ball?
Does this question look familiar? Okay, if you turn the page over to the page last time, it's the exact same problem, except for this one says returns. Okay, one word completely changes your problem. Okay, does this say returns? No. So, what are the chances I pick? How many bones are there to pick? 1, 2, 3.
Out of 6. So 1/2.
How many items are there?
6. Oh wait, no, 7.
7. Okay, 3 out of 7. So this time I literally am taking this bone out. It's not there anymore. I took it away. So now I have 6 options left, and I'm looking for a ball. How many balls are there? Out of 6. Okay. Notice my denominator went down by 1. Okay. I'm going to try to simplify. 2, 6. Can I simplify? What is that? 1/3. Okay. What should I do now? Okay. 1 times 3. 3 times 7.
21.
21. Could I have simplified these 3's right here? Yeah, we didn't. That's okay. Now we have to simplify here by 3. And I get 1. 7th. Everybody okay with that question? Yeah? All right. Anybody else want to read? Okay, go ahead, Amin. Last one.
Mackenzie chooses one candle and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times?
Perfect. Thank you. Again, we saw this question, but it said returns it. But now I'm not returning it. Okay? How many polka dots are there? 2 out of
5.
5. Okay? Again, I literally took it. I did not put it back. Now how many polka dots are there? 1 out of 4. Okay, these are little numbers, so we can multiply. 2 times 1.
2.
5 times 4.
20.
Which equals?
110.
Now again, you could have simplified those 2 4s, but these are small numbers. So if it's small numbers, I don't usually mess with it, but those big numbers are where you want to make sure you cross simplify. Okay? All right, now let's look at the back. We have all these clothes that we just got out of our laundry basket, and we're going to answer some different questions about them. Okay? So first, it says determine if it's dependent or independent, and then find the probability. Okay? So number 8 says the probability of selecting a top and then a bottom. Is this independent or dependent? Why is it dependent?
Because it's after A.
Yeah. It does not say I replaced it. It doesn't say I put it back. Okay? So dependent, denominator changes. But first, how many tops are there? Just 1. Out of how many total items?
16.
Yep, so there's 1 out of 16. Okay? Now, I'm picking a bottom. I literally took this top away. So how many items are there to pick from? 15. And I'm looking for bottoms. Bottoms means skirts or pants.
6.
I got 5. Okay. Can you simplify? Yes, they end in 5s. So it becomes 1.
Wait, let's do this.
Yes.
There's 6 bottoms. Like,
Where?
there's 2 skirts.
Where's the 2 skirts?
Oh, I thought the t-shirt was a skirt for some reason.
Oh, no. Okay. So now we have 1/3. And now top times top. 1. Bottom times bottom is 48. So it's the exact same thing as last time. It's just, if it's dependent, you're taking that denominator away. Okay? Next, what's the probability of selecting a striped sock, replacing it, and another striped? So independent or dependent? Replacing means independent. Okay, replacing means it's independent. So what's the probability I pick a striped sock? 5 out of 16. Now I put it back. So what's my total if I put it back? 16 still. And then stripes again is 5. So 25 and then 16. 16. Do I get 256? Yes, no, maybe? Okay. All right, next one. What's the probability of selecting a towel, replacing it, and then a towel again? It is independent. Why?
Because you're replacing it, so you're putting it back.
Yeah. It says replacing. Okay. So what's the chances I get a towel? Okay, what's the chance I get a towel again?
1 out of 6.
Okay, you already know what 16 times 16 is. What is it?
36. Wait.
256. Yeah, we just did it right here. 256. All right. What's the probability of selecting a skirt and a top? Okay. Does it say if it's independent or dependent? No. So if it doesn't say I replace it, what do you know?
It's dependent.
Yeah, I didn't replace it. It's dependent, which means my denominator changes. So skirt, how many skirts are there? 2 out of 16. Okay, I'm not replacing it. What happens to my denominator? Goes down by 1.
Goes down.
And I'm looking for a top. How many tops are there? 1 top. Can we simplify? Yes, they are even. What can I divide by? 2. So that becomes 1/8. Now top times top equals what? 1. Bottom times bottom is 1 out of 120. All right, last one. What's the probability that I get a matching pair of solid socks? So they have to be solid. Okay? Independent or dependent? Dependent. It didn't say anything about replacing it. And if they're going to match, obviously I'm not going to replace it. Right? How many solid socks are there? Okay?
4.
I'm not putting it back. What's my new total? 15. How many solid are there left for me to pick between? 3.
0.
No, because remember, I only took 1. There were 4, but I only took 1. Okay? Just like when I was talking about these, there's 4, but I'm only picking 1. Okay? All right, can I simplify? Yes, please. Please make my life easy.
Yeah.
I can divide by what? 2 or 4? Let's do 4 because it's bigger. 1/4. Good. Can I simplify over here? Yeah, what does it become? 1/5. 1/5. Again, make sure you're marking these off so you don't get confused. I have 1 times 1 is
1.
4 times 5, 20. Okay? So that is it, okay? Cross simplifying makes your life easier. It goes quicker. If you can cross simplify, try to do that. All right?